undertaking. Just to introduce myself to you or introduce myself to you, this is how I look. And as Dr. Patra said, I did my BSc Tech in Textile Chemistry almost 3 decades back, and have a variety of experience. Started with textile processing, and then did a lot of technical marketing of dyes and chemicals from various companies, global as well as Indian companies. And through this, I did come in touch with Dr. Patra when he was in Maral overseas. And also in the last 8 years, I have now sort of shifted my career goals and focused more on sustainability, chemical management, training, etc. So this has been my expertise over the last 8 years. What I will do is that I will try and keep this presentation not too technical, but trying to give you an overview of where this textile industry is going or heading towards, how fashion is impacting our resources and our environment, and what we should do about it, and how initiatives such as the ZDHC Foundation is now trying to repair the damage that has been done to this earth. This slide actually tells you, or rather captures, how fast fashion is now changing consumption patterns. So traditionally, for some years back, we used to have, say, 2 cycles or 2 seasons, as the fashion industry used to call. But now, due to the fast fashion, that is the use and throw kind of cheap garments that are available, these cycles have increased to almost 50 cycles per year. So you can see many global fashion brands such as Inditex or H&M or CNA, they come out with a very, very fast replacement of garments in their stores, because consumers today just buy a garment and use it once or twice and then throw it away and try to buy new garments. And this is brought out with this figure, a survey which was done a few years back, but which holds true even today, that the average consumer bought 60% more clothing and kept each garment half as long. So you can see that the amount of textile waste, the amount of resources which are being used to produce more and more number of garments is increasing. We also have something on the impact of population. I mean, there has been a huge increase in the production of garments, in the use of garments, mainly also because of the impact of the increase in population. So you can see over here that. Hello. Can all the others please mute themselves, please? Otherwise, we'll have some background noise. Yeah, so I was talking about the impacts of population. So you can see that in around the 1750s, about 200 years back, we had only a population of 700 million. And in those 200 years or 300 years, we are going to grow to about 9.7 billion. So you can imagine that with this growth in population, there is going to be a huge demand on the resources that the earth can provide. And this has really impacted the way the earth is functioning. It has impacted our environment. It has impacted our daily lives. And that is why everybody is now talking about going green. Everywhere you see that people are talking about global warming, global surface temperatures, carbon dioxide emissions, energy consumption, etc. But are we really going green? If you see these graphs which I have put over here, the carbon dioxide concentrations, the greenhouse gases emissions have increased drastically because of an increased production activity or increased activity in factories. The global surface temperatures are rising. I mean, we are trying to desperately try and see how we can bring down these global surface temperatures, because it is said that if the global surface temperatures increase by 2 degrees, then there is a possibility of flooding and the snow melting and flooding the cities. The energy consumption is going up, even consumption of fertilizers and pesticides, which are used for growing crops. You can see a very, very huge upswing. So, although we talk about going green, the actual impact on the ground is exactly the opposite. We are hugely using the resources of the earth. And this is, of course, leading us to sustainability challenges. The first challenge is water consumption. It's been said that we are going to run out of water before we run out of oil. And there is no doubt that our water resources are under severe pressure. And textile production, as you know, is a very, very water intensive process. I mean, we require huge amounts of water to try and dye and print and finish our goods. The second sustainability challenge is water pollution. So, as you know, textile production also leads to a huge amount of wastewater discharge. And since we use a huge amount of chemicals, we use a huge amount of dyes and pigments. All these, if these are not treated properly, will go out in the environment. According to the UN, a child dies from a water-related disease every 15 seconds. So you can see the impact that we have of textile production on our environment. The next challenge that we face is the use of toxic chemicals. And this whole presentation that I am going to talk about now is going to focus on this subject, because ZDHC, as I said, is the Zero Discharge of Hazardous Chemicals initiative. And knowingly or unknowingly, we use a huge amount of toxic chemicals in our textile and apparel production. And these toxic chemicals have a huge impact on health and the environment. I mean, these are some photos that I have shown over here. I mean, there is a huge increase in cancer amongst the human population, and this has been now shown that there are a lot of chemicals which are cancer causing. These are chemicals which are called as carcinogenic, mutagenic, and reprotoxic chemicals, which we use in not only textile but a wide variety of industrial applications. Skin allergies, such as this photo where I've shown a person who has worn a leather shoe and has got this kind of allergies or something on this person on the back. This is also quite common because of chemicals. Air pollution has caused a lot of lung diseases. This is a photograph of a frog which was found with innumerable amount of legs, which is all due to the dangerous effluent which is being let out into the rivers. So let's look at the environmental impact of a t-shirt. So just to make a 250-gram cotton t-shirt, we have to use up 1.7 kilos of fossil fuel, and 2,600 liters of water are consumed right from cotton growing till the finishing stages. And just to make one t-shirt, about 4 kilos equivalent carbon dioxide are liberated into the atmosphere. 142 grams of chemicals are added and 400 grams approximately of solid waste goes into landfill. So you can see the impact that a single t-shirt that we buy can make on the environment. So there is, it's a clear case that we need sustainable chemistry. We need to use chemicals in textile production that does not cause harm on the human health and the environment. Here are some examples that have actually occurred due to the impact or discharge of chemicals. The first photograph shows an incident which happened off the shores of Vietnam due to the release of toxic chemicals into the sea by a steel plant in Taiwan. About almost 70 tons of dead fish were washed up on Vietnam shores because of that. The middle photograph is actually a photograph which I took during one of my audits of a jeans garments manufacturing facility in Mumbai. Here you can see that the workers are spraying potassium permanganate over the garment. The potassium permanganate is sprayed to give the wash down or the fade out effect on jeans. But do you know that these fumes which are being generated when they enter the nose of the workers, they can cause pulmonary edema or waterlogging in the lungs of workers. So they have to use proper protective equipment, but you can see over here that hardly any care is taken for that. The photograph on the right is that of a very famous case which happened in the DuPont factory in USA in Charlottesville. So DuPont was famous for making the Teflon finish, the oil and water repellent finish, which we all use not only in textiles but also on utensils. And this person, Buck, was born of a mother who used to work in the DuPont plant. And he was born with all abnormalities because of the C8 fluorocarbon chemistry, which is used in Teflon. So the C8 chemistry has now been banned and nobody uses this chemistry anymore. You will be a little bit surprised as to why I am showing the photograph of a polar bear when we are talking about chemicals in textiles or chemical management. Well, the idea is that the polar bears, which are far away from us in the Arctic region, a study was done of the fat tissues of these polar bears, and they found a host of harmful chemicals such as flame retardants and fluorocarbons in the fat tissue of these animals. So you can imagine that these are far away from production sites, but still the chemicals have traveled from where we are producing to such far areas. And a very good study was done by Greenpeace, and they published a report called Footprints in the Snow, where they went to remote areas like the Alps and the Himalayas, and they collected the samples of snow from these areas, and they tested it for a host of hazardous chemicals, and they found traces of PFCs, that is perfluoro compounds, and brominated flame retardants in these snow samples. So what I'm trying to say is that it does not matter where we manufacture and use chemicals. Chemicals have been carried through air and water now to all parts of the world. So we really have an earth which has been polluted by these chemicals all across. Now here is some interesting fact to help you understand why we are now talking about sustainable chemistry, or why chemical management is suddenly becoming mainstream in textile production. You may be surprised to know that there are more than 4 million chemical substances which we are manufacturing and which we are using today. So you must be aware of something called as the Chemical Abstract Service, or the CAS number as it is called. So every chemical with a unique footprint or a fingerprint is registered under CAS. And we have 4 million such kind of chemical substances, which are not only used in textile, but in all other kinds of applications like fibers and pharmaceuticals and construction and polymers and rubber and other industries. But the most surprising fact is that we do not know the impact on human health for almost 80% of these substances. So we have just started manufacturing these substances, but we are not aware whether these are harmful to human health, how they will impact the environment. We have just started making and using it. And there are almost more than 800 chemical substances which are used in our textile and leather production, which we know are harmful. So a study has been done, and we know that these are harmful to human health and environment, but still these are widely used in this part of the world, either because we are not aware of them, or maybe because we feel that they are cheap, and so we don't want to substitute these with safer alternatives. And this is where we focus on. We are focusing on the leather and textile production to see that at least those known substances are eliminated from the production processes. So how do chemicals impact us? So impact is definitely either on human health or on the environment. And these are some of the hazard endpoints that are now being used to classify a product as hazardous substance. So what do you mean by a chemical substance being called hazardous? So these are the hazard endpoints which a chemical should be checked for. And if it is having any of these properties, then it is termed as hazardous. So the first is toxicity. So quite say maybe 2 decades back, toxicity was the endpoint to determine whether a chemical was hazardous. So if it caused death either through oral, that is through the mouth, or through the skin, or through the respiratory tract exposure, then that chemical was harmful. The next endpoint was skin or eye irritation or sensitization. But in the last decade or so, very new impacts of chemicals have come to light. And some of these are what we are popularly called as CMR, as I referred to earlier. That is carcinogenic, mutagenic, reprotoxic. That is chemicals which can cause cancer. They can cause a change in the gene structure. That is, they are mutagenic, or they can impact your reproductive system. That is, they are reprotoxic. So such kind of chemicals are really harmful to us. The next endpoint is called as endocrine disruptor. So what do you mean by endocrine disruptor? So in our human body, we have the endocrine system, which secretes hormones. So these hormones are also chemicals, which are secreted in very, very minute quantities. Now, there are certain chemicals which are also used in our textile production, which are very similar in chemical structure to these hormones. And so when they enter our human body, they can disrupt this endocrine system. The brain doesn't understand which is the hormone and what is the chemical, and can then lead to hormonal imbalance and a lot of health impacts. There are some chemicals which are specific target organ toxic. That means they don't kill you. They are not carcinogenic. They are not endocrine disruptors, but they go and target a specific organ in the body, such as the heart or the kidney or the lungs, and then they damage that organ. Lead is an example of that. Even cadmium is an example of specific target organ toxic chemical. And then there are chemicals which are neurotoxic or a developmental toxin. So they inhibit the development in children, or they affect your central nervous system. So these are all different impacts that chemicals can have on human health. Similarly, they have impacts on environment. And one of the main impacts is called as PBT, that is persistent bioaccumulative and aquatic toxic. Persistent means it doesn't biodegrade. The chemical remains in the environment for a long length of time. So for example, the plastic bottles. So we say no to plastic because a plastic bottle or plastic polymer can remain in the environment for more than 300, 400 years. Similarly, the fluorocarbons that we use for oil and water repellency can remain in the environment for many years. So these chemicals are persistent, and there are some which are bioaccumulative. That is, they are not soluble in water, but they go and accumulate in the fat tissues. So I showed you the picture of the polar bear. So they analyzed the fat tissue and found these flame retardants and other hazardous chemicals there. So these are chemicals which do not go out of the body through the water, but they go and accumulate in the fat tissue. And of course, then you have chemicals which are aquatic toxic. That is, they can damage or kill the aquatic life. Then there are chemicals which are volatile, especially chemicals such as solvents, which can cause a depletion of the ozone layer. in the atmosphere. And as you know, if the ozone layer is depleted, we are then getting exposed to the harsh UV rays of the sun. Similarly, we have air and water pollution. So we have air pollution in terms of toxic gases such as NOx and SOx, that is nitrous oxide and sulfur dioxide emissions. And we have water pollution in terms of AOX, we have COD, we have BOD. So these kinds of impacts can have a huge effect on the water bodies. And then we have one impact called eutrophication. Eutrophication means the uncontrolled growth of algae on a water surface body. So you must have seen many times on lakes and all, a huge greenish kind of layer, which is uncontrolled growth of algae. And this is called as eutrophication because it prevents the sunlight from going into the water, and thereby it affects the aquatic life below. This eutrophication is also caused due to a lot of usage of urea-based or phosphate-based chemicals in the textile industry. So under the GHS, that is the globally harmonized system, we actually have now defined 18 hazard endpoints, which each chemical has to be checked to see if it is hazardous. Getting into a little bit of chemistry over here. So these are some of the chemical groups which are widely used in textile application, which are known to cause harm. And ZDHC initiative is actually about trying to avoid and eliminate these kind of chemicals in the production of textiles and leather. So you have something called as AP and APEOs, that is alkyl phenol ethylene oxide condensates, which are known to be an endocrine disruptor. So if they go into our body, they can disrupt our hormonal balance, and they also are aquatic toxic. They are widely used as wetting agents, detergents, and emulsifiers. Then you have chlorophenols, which can cause cancer. They are used as preservatives. We have a lot of Azo dyes. I am sure you must have heard of Azo dyes, which is one class of dyes. Not all Azo dyes are harmful, but there are certain Azo dyes which can cleave to form some amines, and these amines can cause bladder cancer if they go into your body. And a lot of dispersed direct acid, basic, and reactive dyes are in this class. There are some dyes which are carcinogenic. There are some dispersed dyes which are sensitizing, that is, they can cause skin allergies. We have some glycols, solvents, and volatile organic compounds which are carcinogenic and which can cause ozone depletion. A lot of heavy metals are STOT is specific target organ toxic. We have organotins, which are widely used in coating materials, in PVC and polyurethane coatings as catalysts. These are mutagenic. We have polycyclic aromatic hydrocarbons. We have PFCs, that is perfluorinated compounds. And we have phthalates, which are used as plasticizers in printing. In chest printing or as leveling agents. So these are various applications. I just wanted to try and highlight that there are a host of harmful substances, as I said, more than 800 substances which we use in various formulations in our textile production, which can cause harm to human health or the environment. And it is extremely important for us to understand and manage responsibly the chemicals in the textile factory, because on an average, a textile factory consumes about 150 to 200 different kinds of chemical formulations. And all these can go out of the factory in 4 pathways. The first is on the product itself. So because that is where we are doing the processing, we want to color it, we want to finish it, we give some kind of softness. So a lot of chemicals are found on the product itself, which we wear, or sometimes the children put it in their mouth, and then these chemical residues can be absorbed to the skin or the mouth. And the second impact is also when it is there finally discarded to landfill, these chemicals can leach out into the soil. The second pathway is the wastewater and the sludge, because as you know, a lot of water is used to transfer these chemicals to the products, but not all these chemicals go onto the product. A lot of them are finally discharged in the wastewater and the sludge. So through the sludge, it can affect the crops, it can contaminate the soil, and through the wastewater, if it is not treated properly, it can lead to water pollution, death of fish, and biomagnification. Biomagnification means that the chemical can go in some aquatic life, such as fish, and then that fish, when it is eaten by the higher animals, including us, it can come back on our plate. And finally, we have the waste gases, from the factory, which can lead to respiratory hazards and ozone depletion. So there is no doubt that chemical management has to be a responsible feature in textile production, and this was highlighted by an NGO called as Greenpeace. Greenpeace is a global not-for-profit organization which focuses on various issues, environmental issues, or any kind of issue which is impacting our earth. And in 2012, they actually took up a campaign to highlight the pollution which is caused by the textile industry. So you can see in this photograph a Greenpeace volunteer who is collecting a sample of the wastewater which is being just let out from some mill. This was in China actually. And subsequent to 2012, they carried out a host of campaigns and they published reports which are famously known as dirty laundry or toxic threads. So if you go on the Greenpeace website and type out these words, dirty laundry or toxic threads, you will be able to download these reports. These are very, very professionally made reports in which they showed that the textile industry is still using a lot of hazardous chemicals and still discharging these chemicals into the rivers and really polluting it. And it's not only limited to China, they went to Mexico, they went to Bangladesh. They tested the garments which are being sold by the brand which you and me go in the shop and buy. And they did find all these chemicals that I spoke about in the earlier slide. So in 2012, Greenpeace actually rolled out a campaign which they called as Detox now. Detox is detoxify. And you can see over here in Europe, the Greenpeace volunteers actually demonstrated in front of the stores of various brands. And they challenged these brands to commit their entire supply chain to shift to zero toxic chemicals across all pathways. So the detox campaign really shook up the fashion industry. It was a direct challenge to how the brands are manufacturing their products. It was a direct challenge to their supply chain partners, and it was a direct challenge for consumer safety. And the brands realized that there needs to be a mindset change, because this kind of campaign or this kind of challenge could not be done by a single brand or it could not be done by a single organization. So it needed three things. One was collaboration across the industry, collaboration with all stakeholders in the industry. We needed a lot of transparency within the entire supply chain because today the brands are sourcing through a very, very fragmented supply chain. And many times they don't know, who are their actual suppliers. So they needed to establish a mapping of the supply chain and a transparency into what is happening actually within their suppliers. And thirdly, it needed a commitment across all tiers of the value chain. So it didn't mean that only the brands were committed to this change. It also meant that every part of this chain had to commit and had to ensure and implement a set of actions to change the way they were working. And this is how the ZDHC was formed in response to the detox campaign by Greenpeace. So as I said, in 2011, 2012, for one full year, Greenpeace had this campaign. and multiple brands decided to collaborate. They decided to join hands together to form a single initiative, which was called as Zero Discharge of Hazardous Chemicals, or ZDHC. So this was formed in Q1 in 2012, and it was a loose collaboration of brands where six brands initially came together, and slowly more brands joined in. And in 2015, they realized that it needed to be a legal entity. It needed to be an organization, a structured organization, which would start activities on behalf of the member brands. And hence, in 2015, the ZDHC Foundation was registered in Amsterdam as a not-for-profit organization, and it started its activities on behalf of this brand. So we now have a structured organization with a board of directors, an executive director, and various employees, where the idea was to develop a range of tools and guidelines to implement such a program, and also to look beyond the brand. So it became a multi-stakeholder organization where we also brought in textile companies, chemical companies, service providers also as our members to try and have a multi-stakeholder collaboration. And from 2020 onwards, this ZDHC is now being transformed to something called as a roadmap to zero. That is from a finite goal, because in 2015, or rather in 2012, these brands had committed by 2020 as a deadline to eliminate these hazardous substances from the supply chain. But it is very clear now that this is going to be a moving target. It is not going to be a static goal, because newer chemicals, newer substances are being discovered to have impacts on, and need to ensure that a continuous improvement in the actions are being done by the textile industry to ensure that we safeguard so the use of sustainable chemistry in the textile processing. So this slide shows a quick snapshot of our members. We have now more than 33 signatory brands. So all the multi-billion brands are members of, and it's growing. More and more brands are coming. Walmart has also joined us this year. And then we have various leading companies from the chemical industry, from the textile and footwear industry, from service providers or solution providers, and also associations who can become our members. So what is ZDHC all about? Our vision is widespread implementation of sustainable chemistry, driving innovations, because we know that there are still certain chemicals or certain substances where we need to find safer alternatives. And thirdly, to implement best practices for environmental and chemical management in the textile, apparel, leather, and footwear industries. So we are focusing on these two industries, the textile and leather industry. And the overall aim is not just to protect consumers, but also the workers and the environment from the harmful effects of chemicals which are used in textile and leather production. So ZDHC actually moves deeper from a product compliance, that is what is popularly known as product safety, to a more proactive supply chain management and innovation leadership. So it goes deeper into the supply chain. We are connecting with textile mills and factories and leather tanneries, which are actually using and discharging chemicals in a huge way, and trying to implement systems in these factories to prevent not just the discharge, but also the use of proper chemicals. So what is the ZDHC approach? The ZDHC approach to chemical management is a holistic approach to the three major focus areas, as we call it. So we have input, process, and output. So in any textile factory, If you have a lot of chemicals, you have a lot of raw materials such as yarns and fibers and fabrics which are coming in, then these are processed. So we have various processes right from sizing to pre-treatment to dyeing, finishing, printing, coating. And then finally, all these chemicals are going in the output, either in the wastewater or in the sludge or in the air. So in each of these three areas, ZDHC has defined certain standards or certain guidelines and certain tools for the supply chain partners to implement sustainable chemistry. So let's start with input chemical management. So input chemical management, and I'm not getting into too much details, but just to give you an idea of what we do and how responsible chemical management can be implemented. This is through two ways. As I said, we have a guideline which is called as the ZDHC MRSL. Now you need to understand this because when you go out in the industry, you will hear these words such as manufacturing restricted substances list or restricted substances list. So when we say that we have to eliminate hazardous substances, first of all, we need to know what we need to eliminate. So ZDHC has compiled with a collaboration with brands and all our stakeholders, a list of substances, harmful substances, which are banned from intentional use in chemical formulation. So the idea of input chemical management is that if you prevent these substances or these chemicals in your input chemicals itself, then you will have less of problems in your process and in your output. So the idea is that let's first have a filter or a security guard at your input chemical formulation itself. So the whole focus of ZDHC is on input chemical management. And to help the supply chain partners of the brands in purchasing MRSL conformant chemicals, we have developed a platform, we have developed a tool called as the ZDHC Gateway. So we have got in touch with the chemical industry worldwide, and we have listed, we have screened commercial chemical formulations that are conformant to the ZDHC MRSL, and we have listed this in a database on this gateway, on this platform. So the supplier facilities, the manufacturing facilities of all our brands can access this gateway and they can check their inventory, they can source, they can confirm and find and search for safer chemicals to be used in their factories. So this is a very, very easy way. Today we have more than 35,000 commercial chemical formulations which are listed on the gateway, and more than 3,000 chemical and dyes suppliers which are registered on the gateway. For the process management, it is how you are managing the chemicals once it enters your factory. So once the chemicals come in, how do you ensure proper storage and handling? How do you prepare and document your chemical inventory? How do you ensure proper health and safety of your workers who are exposed to these chemicals? How do you manage your output management? How do you do your documentation, general maintenance and housekeeping? How do you manage your incidents of any chemical accidents? And finally, a continuous improvement for through internal audits or through training of the personnel in the factory. These are all given as a guidance document which we call as the ZDHC CMS framework. CMS stands for Chemical Management System. So ZDHC helps factories in their process management by giving guidelines as to how they can implement a system for managing chemicals in their factory. This document is also available on our website and anybody can download it for free. And finally, we have the output management. As of now, we have published the wastewater guideline, but by the end of this year, we will also come out with the air emissions guideline. For the first time, the ZDHC has established wastewater norms, which includes not only conventional parameters. So you can see a list of what we call as conventional parameters. These are normally implemented or requested by the legal authorities. by the pollution control boards. But we not only require our supplier factories to test these, but also the MRSL chemical groups. So there are about 20 MRSL groups which need to be tested in the wastewater being discharged. And if there are any non-conformities to these guidelines, to these limit values, then the factory is supposed to undertake a corrective action. They have to analyze what is the root cause and take some corrective action and ensure that these harmful substances are not discharged to the environment. So this wastewater guidelines is a industry standard which outlines limit values, test methods, even sampling points in a facility's wastewater treatment. And all the factories, all the suppliers, and there are more than 6,000 textile mills which are registered on the gateway who are supplying to our ZDHC brands. We require that they test this wastewater to our wastewater guidelines twice in a year, and they upload these reports on the gateway so that the brands can monitor the activities and the compliance of these factories. So to summarize responsible chemical management, the ZDHC's approach, as I said, we approach the whole industry in three focus areas: the input, process, and output. So as a responsible textile manufacturer, you need to ensure that you are managing your chemicals in the input area, in the process area, and in the output area. And in each of these, as I said, we have some guidelines, some standards, and some tools that help the suppliers to implement these standards. So for the input, the chemical formulations should be conformant to the MRSL. They should try and use the ZDHC gateway to source their and purchase their chemicals for all kinds of raw materials such as gray fabrics or dyed yarns or even trims and accessories. They should test these materials for the restricted substances norms. For the process area, wherever there is all wet processes, they should use the ZDHC CMS framework to establish a chemical management system right from the purchase, use, storage, handling, and disposal of the chemicals and the chemical containers. And finally, we have the output, in which we have the end products, the wastewater and air, where we have standards. Like for the products, we have every brand's RSL norm, that is the restricted substances list. And we have the ZDHC wastewater guidelines and the air emissions guidelines, which should be followed by all the supplier facilities. So in this way, in this structured way, ZDHC is trying to bring about a positive impact in the textile and leather factories across the world and ensure a responsible chemical management so that we have a better world, we have lesser impact on human health and the environment due to our industry, because our industry is looked upon as a highly polluting industry. And all of you as textile students and textile graduates, when you go out in the industry, you will always face this issue because we always are looked upon as people who are causing a lot of pollution to the environment. So the ZDHC initiative is something which is trying to mend these ways, which is trying to improve these ways, and trying to ensure that our textile production is not causing any damage to the earth. I would like to end this presentation with a small quote by Hubert Reeves. Hubert Reeves is a philosopher, and I really like this quote of his. And he says that man is the most insane species. He worships an invisible God and destroys a visible nature, unaware that the nature he is destroying is this God that he is worshipping. So with this message and with this presentation, I hope you liked this presentation, you were able to get an idea, as Dr. Patra had said, what is ZDHC, why it is important that we all, as when you go out in industry, you must keep in mind that we have to behave responsibly towards nature, towards environment, and ensure that we implement sustainability and sustainable chemical management practices in the factories that we work. With that, I am ready to take questions. And Dr. Patra, if you would like to add anything or say anything, we can hear from you, and then we can take the questions.
It was really a wonderful presentation, and it's really nice that you could take us through the basic attributes of the zero discharge of hazardous chemicals. I have just one question to ask you. Now we are already in a, say, kind of carbon-intensive growth path as far as the textile industry is concerned. And there are many standards like GOTS, that is Global Organic Textile Standard, then we have REACH. So that way ZDHC is not a lone voice in the woods. But then do we have any unified approach so that we can comply to all the requirements that the present day standards aim at?
Yeah, so in fact, one of the main objectives of ZDHC is to try and harmonize these standards. So if you see, ZDHC is not a certification. Let me clarify that it is not a certificate like a GOTS or a Ecotech that you hang it on the wall. It's a set of actions that a factory has to do and continuously monitor. So we have never gone into any kind of certification, and we are trying to harmonize these existing standards also, because if you see, our ZDHC MRSL is now adopted by GOTS, it is adopted by Ecotex, it is adopted by Blue Sign. So, and ZDHC also recognizes these existing standards as being conformant to MRSL. So when I said that we have listed out a database of chemicals which are ZDHC conformant, MRSL conformant, what we have done is we have actually looked at these third-party approved certifiers, and we have taken GOTS, Blue Sign, a host of other certifiers already existing, and if they all meet the ZDHC MRSL requirement, these are already approved by ZDHC. So there is no need for any duplication to be done for ZDHC. So in this way, we are trying to harmonize the standard. We are trying to harmonize also the brand's approaches. So earlier, each brand or each apparel brand had its own standard, or its own method to approach this problem. But now there is a huge harmonization in the approaches that the brand also do. Having said that, there could still be requirements of a specific standard, because, for example, if you say GOTS, it is specifically applicable to organic cotton. So if anybody is doing organic cotton, they still might have to go and do this GOTS. But the converse is true, that if you are already doing GOTS, you are already complying with the ZDHC input chemical management. Hope it answers your question.
Yeah.
Pansar,
Mr. Yogesh.
Yeah, I just have a question for you, which I asked in many platforms also. ZDHC, GOTS, Blue Sign, most of the people are talk about textiles, right?
Yeah.
But most of the energy expense for a garment takes place in the laundry stage, which is at the customer end. Now, when the customer does his washing, you have a lot of soaps, and you have a lot of chemicals in the soaps which can, decrease the oxygen in the water, and it can be harmful to fishes. So basically, the customer is creating a load which may be much higher than even the mills.
Yeah, you are absolutely right.
So
actually.
how not many of the compliances, not many of the organizations are catering to this problem, the load which is generated by the customer.
Yeah, you're right. In fact, I remember there was a study which was done by Levi's on the consumption of water in the production of one jeans, and they found
Hmm.
the maximum consumption is actually by the consumer. So they took it right from the cotton growing till the consumer, usage, end of life, and they found that the maximum, of course, is also in cotton growing, but more than processing, the water consumption was more at the consumer end because they kept on washing the jeans a number of times. So you are right. I mean, a lot of chemicals are also used at the consumer end. Detergents are used, or some nowadays softeners are used, and there is also the issue of the usage of water, or energy consumption at the consumer end. Unfortunately, ZDHC is not focused on that as of now. We are first trying to look at the value chains or the immediate suppliers, so whether these are the wet processing mills, the garment laundries, printers, leather tanneries, this is where the focus is of ZDHC right now, and
I
that's
mean,
the
even
huge challenge.
even in the COVID-19 situation where the water is very clear, you
Hmm.
can still see soap water in the rivers
Yeah, yeah.
because the customers are still washing the clothes, so they are still generating the soap. There is still pollution from the customer end.
Yeah, so that is a different space that we are talking about, and that would be educating customers, ensuring some proper legislation in the use of detergents at the consumer end. So I don't think ZDHC is going to get into it very soon. We are just focusing on the actual production segment.
Mhm. Any questions, Dr. Patra, from anyone else?
Uh,
Dr. Suman,
well,
ma'am?
yeah, Mr. Pant, although there is a kind of roadmap, like still, what do you perceive to be the deadline for elimination of the hazardous waste, and how do we really accomplish it?
So in 2012, when this movement started and the ZDHC was formed by the brands, they took that 8 years. They said that by 2020 we will ensure that all our supplier chain, these chemicals will be eliminated and all. But then as they started on the journey, they realized that it's a very very complex issue, because first of all, the supply chain is so fragmented. To get data, on what kind of chemicals they are using and what kind of waste water equipment they have itself is a big task. So I don't think we can talk about a deadline, for
Okay.
hazardous waste. As I said, uh, almost 80% of the chemical substances which we are still using everywhere, we do not have enough data to on the hazard endpoint. We don't know. I mean, new findings are coming up every day. So you can see the REACH law in the European Union. You will find that almost every month or every 2 months, new SVHCs, that is substances of very high concerns, are being added to the list. So it is always a moving target. I think, like even in ZDHC, we have now come out with the MRSL version 2.0, where we have added almost 64 new substances which were earlier not there in the earlier MRSL, but they are known to be harmful. And so that 2.0 is now going to be implemented in one or 2 years. Then we have 3.0, that there will be new findings of substances, of harmful or hazardous substances. So I think it's always a moving target. We can never say that there will be a deadline where everything will. You know.
To my understanding, ZDHC deals, other than textiles, with footwear as well as leather.
Correct.
And Kanpur is in fact a hub for leather industries. We have a lot of tanneries here as well, and also to quite an extent footwear.
Yeah.
So your comments on those areas where the restrictions of the chemicals are there. So
Yeah. So Kanpur, Chennai, Ranipet, Ambadur, these are all centers in India where there are huge tanneries. And there are in Agra also there are a lot of footwear companies. Um, Unfortunately, the ZDHC initiative in the last 5 years has been focused on export-oriented units. You know, those who were supplying to these brands. Uh, we are not yet reached out or made any footprint in the local or domestic industry. So the domestic industry is still okay. They do comply with the pollution norms of the government, but on a wider scale, on a global scale, these companies are not yet engaged into ZDHC because that is not really a requirement. Because this whole thing comes into play when the brands start demanding these requirements from the supplier. You know? However, having said that, we are, I mean, because of the COVID impact, it has become a little bit difficult now, but we had already started trying to engage with the domestic industry also. In Kanpur, we had organized a seminar to make people aware. In Chennai, also, we are doing it. We are running a lot of training programs or awareness workshops through some other accredited laboratories of ours, like TÜV and TÜV Rhineland. They are conducting various workshops in these clusters so that people at least start getting aware of what is this ZDHC, and then we can look at trying to support these factories in implementing these various solutions and standards.
Okay. So since you uttered about COVID, you advised our students post-pandemic in terms of opportunities and career options.
I think sustainability is going to be, or hygiene, safety, sustainability. These are going, or even the elimination of harmful substances. These are going to be top priority post COVID because everybody has seen what virus or what kind of impact um, something which can damage our health can do. And, can see the in the developments that are happening. Of course, the industry has not restarted in a big way, but we can already see that the demand for antimicrobial finishes or antiviral finishes, or trying to ensure that the fabrics are safe to consumers will definitely grow. And hence, I think students in the post-pandemic situation, the opportunities are there for people who like to take up chemical management, expertise, sustainability practices. Uh, these kind of opportunities, I'm sure, will grow. So you can have a career now, and we can also see in the last 2 or 3 years, many brands are also for chemical management. So they need somebody in a factory who understands about these chemicals, who can implement the chemical management system, who can do all the kind of requirements that are there for ZDHC.
Okay. So the RSL, or the restricted substances list, which ZDHC emphasizes on. So in that, what are the major culprits? What components you very often find? And if we can eliminate them, then probably to a larger extent, the problem of effluent generation can be managed.
Yeah, so there are many major restricted substances groups. One of them is the alkyl phenol ethoxylates. So these are widely used in a variety of chemical formulations because they can be applied as wetting agents, they can be applied as covering, for washing, detergency, even in emulsification. So right from your knitting and coning oils to the finishing softeners, these APEOs are widely used. And we need to ensure that, and we have safer alternatives. We have the fatty alcohol ethoxylates, and a lot of chemical companies are now doing away with APOs, but that is one of the major problems in auxiliaries. Then you have the issue of in many products we have these phthalates which are used, and then the next problem is about heavy metals, because there are some metals which are like mercury, lead, arsenic, which are quite widely used as catalysts and all in the manufacture of dyes. And then these need to be controlled by the dye stuff manufacturer. The third, I think, is also in dyes. It is about these Azo Dyes, the banned amines which are used. So you have a lot of dyes where the starting raw materials are based on some of these amines, which can finally find some place in the final product or the final dye stuff or the pigment. So I think these 3 or 4. The next one is formaldehyde. It is used widely in a variety of applications, right from dye fixing agents to resin finishes to many other finishing chemicals. So these are all major problem areas which we normally find in textile companies, and these are the areas that we have to take priority.
Okay. So, Mr. Yogesh, any questions you have?
No, I think if there is no more questions, we can give the vote of thanks.
Okay, that was really wonderful to have you here, Mr. Pant, and thank you very much for churning out time out of your busy schedule. I know you have web meetings and calls lined up for today afternoon also. So thank you very much, and we really look forward to have you again with us whenever we get an opportunity. And with this, I think I would also suggest the participants to just visit the ZDHC website, and there you have got literature on waste management, isn't it, Mr. Pant?
Yeah. So our website is roadmap20.com. So it's one single word, roadmap20. So ROADMAPTOZERO.com. So that is our website. So you can, I would really encourage all the students to go and check this website, because you'll find a host of information about ZDHC activities and what we are doing for chemical management. And it will help you to prepare in your career when you go in the industry.
Correct. So thank you very much again. And thank you, Mr. Yogesh, for collaborating with the Institute. And I presume that in future also we'll have many more such activities, UPTTI and SDC together. And finally, I thank all the participants and wish to see you soon. Thank you.
Thank you. Thank you all. Thank you very much.
Thank you very much, Yogesh, and thank you, Dr. Patra. And it was a pleasure to be with all of you.
Thank you, sir.
Thank you.
Same here.
Thank you.